Let's say you put a cup of water in the microwave. You set it for 2 minutes. When it's done, the water looks completely harmless. No bubbles. No movement. No steam. It doesn't even look hot. Then you drop in a tea bag and the entire cup explodes upward. Not because the microwave malfunctioned. Not because the cup cracked. But because the water was already too hot to stay liquid. Every year, people end up in emergency rooms because of this. And almost nobody warns you about it. The dangerous part isn't the microwave. It's the physics. Most people think boiling happens when water reaches 100 degrees Celsius. But that's not actually what boiling is. Temperature alone isn't enough. Boiling is really the process of liquid water turning into vapor bubbles inside the liquid. And for those bubbles to exist, the water needs somewhere to start them. Tiny imperfections. Microscopic scratches. Dust particles. Rough surfaces. These are called nucleation sites. Inside a normal pot, the surface is covered with millions of tiny imperfections. So as the water heats up, bubbles constantly form at those locations. The bubbles rise upward, carry heat away, and release energy as steam. That's why water in a pot behaves so predictably. The moment it reaches boiling temperature, the excess energy escapes. So the temperature stabilizes around 100 degrees. Microwaves heat water in a completely different way. A stove heats from the bottom. But microwaves excite water molecules throughout the entire cup at once. And that's where things start getting weird. Most microwave-safe cups are extremely smooth. Glass. Ceramic. Clean surfaces. Which means there may be very few places where bubbles can actually begin forming. So now you have a strange situation. The water keeps absorbing energy, but it still can't boil properly. No bubbles form. No steam escapes. The surface stays calm. Which means the temperature can climb past the normal boiling point. 105 degrees. 108. Sometimes even higher. While the water still looks completely motionless. This state is called superheating. Now here's the dangerous part. Superheated water is unstable. Physicists call this a metastable state. The water already has enough energy to become gas. But it still hasn't found a way to begin the transition. It's basically waiting for permission. And the moment you disturb it, you suddenly create a nucleation site. Maybe it's a spoon. A tea bag. Sugar. Instant coffee. Even stirring the cup too aggressively can do it. And the moment one tiny bubble successfully forms, everything changes. Steam occupies dramatically more space than liquid water. Roughly 1,600 times more volume. So when superheated water suddenly starts boiling, it doesn't gently simmer. It flashes into vapor violently. The trapped energy releases all at once. And because it happens near the surface, the expanding steam can throw boiling water directly upward. Toward your hands. Your face. Your eyes. Which is why this seemingly harmless kitchen accident can cause severe burns in less than a second. But this raises a deeper question. Why does water need nucleation sites at all? Why can't bubbles just appear naturally? The answer comes down to surface tension. Water molecules strongly attract each other. So creating a tiny bubble means pushing surrounding molecules apart. And strangely, small bubbles are actually harder to create than large ones. Very tiny bubbles have enormous curvature. And that curvature creates pressure. So unless enough energy is concentrated in one place, the bubble collapses instantly. That's the barrier. The water wants to boil. But it can't cross the activation threshold on its own. So it remains trapped in this suspended state. Liquid, despite being above its normal boiling temperature. And this idea turns out to be much bigger than microwaves. The exact same physics appears all over nature. Supercooled water can stay liquid below 0 degrees until one tiny crystal triggers instant freezing. Supersaturated solutions suddenly crystallize when disturbed. Even stars rely on a similar idea. Fusion inside stars only happens because particles occasionally overcome an energy barrier that normally keeps them apart. Metastability is everywhere. Matter is constantly balancing between states, waiting for the right trigger. Fortunately, avoiding superheated water is easy. 3 habits reduce the risk dramatically. First, don't microwave plain water for excessive amounts of time, especially more than about 2 minutes at full power. Second, place something non-metallic in the cup before heating. A wooden stir stick, a plastic spoon, even a grain of sugar helps create nucleation sites. And third, after heating, let the cup sit for around 30 seconds before touching it. If the water is unstable, giving it time helps it settle safely. What's fascinating about this isn't just the danger. It's the reminder. A cup of water sitting quietly on a counter looks like the most ordinary object imaginable. But underneath that calm surface, billions of molecules are constantly negotiating with the laws of thermodynamics. Most of the time, the negotiation goes smoothly. But in the right conditions, inside a microwave, inside a perfectly smooth cup, the system breaks. And suddenly, the hidden physics becomes visible. Which is maybe the strangest part of science. The universe doesn't reserve its deepest rules for black holes or particle accelerators. Sometimes, they are sitting quietly in your kitchen, waiting for a tea bag. Follow for more videos. See you in the next one.